record here. So what we're going to do is we're going to finish up the last section of chapter 3. Sorry, chapter 11. I got to get in the right class. Chapter 11. And then we're going to do a review on Tuesday. And then the test will be on Thursday, the 11th. So we're already almost halfway through April already, which is just crazy to me. We're moving into the second week of April. So next week we'll do review on Tuesday, and then Thursday we'll take the test, just like what we've been doing. You'll, put your camera on, take the test, turn in the work, and then the last, let's see. So the last 2 weeks we're going to cover chapter 12 and 13. But it's just kind of, I pick out the sections that are important for you guys to know. And they're more applications than what we've been doing, which is kind of nice. Okay, and we go in the opposite direction. So what we're going to do today is we're going to finish up this one problem this is part 2. So I just wanted to finish it real quick for you. Is there anything on here on this volume 1 that you feel like you're just not getting, or that you're not quite understanding? I was able, let's see, I don't know if I have it with me. I was able to actually show this, what this looks like. Yeah, here it is. What this looks like on a box form. So let me see if you guys can actually see this. So this is the idea. You have a rectangular sheet of paper, and then what they do is they're taking out squares from each corner. I can get this to not be so blurry. So they take squares out of each corner, and then what they're doing is they're folding these sides up like this, so you end up with a 3-dimensional box. That's what we're doing. And so the question is, how big of a square, or what's the length of each side of the square, so that we get maximum volume. And if you notice on this one, if we don't know this cut right here, that's what we're calling X. And so X is the same as the height. So we have the height of the figure, we have the length of the figure, and we have the width of the figure is here. Okay, so that's the idea behind it. That's the physical aspect of it. So being able to identify this distance right here as our X, which is our height, then we can rename our length, width, and height all with one variable. And that's always the goal, is we always want to have just one variable in our function. So let me share my screen here. And we're just going to walk through this last one. Get all this stuff out of my way. Okay, so again, our height and our unknown cut to create these rectangles is X. So X and height is the same. So with that in mind, now I can figure out what my length is. So the total length is 12, but we took out two X's, an X here and an X here. So that's where we get our 12 minus 2X. And then the same thing with our width. Our total width is 10, but we have an X here and an X here that we took out. So that's, I don't know where that times came in from. So that's where the 10 minus, oh, come on. It's not working. There it goes. Minus 2X comes from. Okay, so now we have everything we need to get our maximum volume of length, width, and height. And if you noticed, after class on Tuesday, I entered, because I think, Orlin, you asked me for it, all the formulas, and I thought, I need to get that out to you sooner rather than later. So in your, let me see if I can find it real quick. In your module 3, let's see, in module 3, boy, this thing is slow today. Okay, in module 3, under your test 3 formula sheets, there was one other sheet that was in there, this one, but the second one has all the information that you need in a little bit easier way to read it. Okay, so here's all the formula sheets. There's your cost function, there's your revenue function, there's the profit function, and then here's area of a rectangle, perimeter of a rectangle, volume of a rectangular prism, volume of a cylinder, and then the quadratic formula. So if you think of anything, any other formulas that you use on this, I couldn't think of any other ones, but if you think of one, let me know and I will add to it and make sure that you have that. Okay, so there's our volume formula. So now all we have to do is find our constraint, right? So the constraint is the shortest side. So between length and width, I realize X is the shortest side, but between the length and the width, that's going to be our constraint. That's what's going to hold us back. So we end up with X, negative 2X, greater than or equal to negative 10. So X is going to be less than or equal to 5. So we have our endpoints between 0 and 5. Okay, and then from that point, now we're just going to set up our volume formula. So our volume is length, width, and height. Our length is 12 minus 2x. Our width is 10 minus 2x. And our height is x. So again, what we don't want, if I wasn't thinking and I wrote height, you can see I have 2 different variables. That's going to be very, very difficult to work with. And we'll end up having to do, because this is multiplication, we'd end up having to do the product rule, and nobody needs to do that. So we're going to keep this, always make sure that all your variables are the same. So whatever you got to do here in the setup, right, in this setup right here, will allow us to have all one variable. And then what I'm going to do is just start simplifying this. So this X by itself, I'm going to save for later. And so I'm going to do my FOIL. So 12 times 10 is 120. The outside is negative 24x. The inside is negative 20x. And the last is a positive 4x squared. And then I'm going to add my like terms. So minus 44x plus 4x squared. And now I can distribute this x through. So my original objective function is 120x minus 44x squared plus 4x cubed. Okay, so I'm going to rearrange this because it just makes me feel better about myself that I have it in descending order. Okay, so this is the objective function with all the constraints embedded. So this is, again, a very specific function for this very specific scenario. Okay. All right. So next step, we have our endpoints. So we're good there. Next step, we're going to find our derivative. So 3 times 4 is 12, subtract off 1. 2 times negative 44 is negative 88x, subtract off 1, and then take off that x. So again, I have x squared, so I have a quadratic, which means I can either factor it or I can use a quadratic formula. Okay, now you can use the quadratic formula with these larger numbers. That's completely up to you. Just a personal preference, I just go ahead and factor out my greatest common factor. To me, it just feels better. And then we're going to set that to 0. Now I have much smaller values, and these are all values that are individual, right? There's no common number that can be taken out of all of them. So the 4 is the greatest common factor. Okay, so I actually tried this. I actually tried to find factors of 90 that give me negative 22. And we were so close. We had, I think it was negative, let's see, what was it? 90 divided by, is it 18? Yeah, so we had negative 18 times negative 5, but when you add those, you get negative 23. And then what was the other one? So 9 and 10 would give you negative 19. And then 90 divided by 6 is 15. So negative 15 times negative 6, that gave me negative 21. So we were so close, but it just wasn't going to happen. So you can always test and see if there's, if there's a way to factor, because factoring is so much faster and easier. But with this one, factoring didn't work. So we're going to use the quadratic formula. Okay, so we have our x value is going to be negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Now, again, if you chose to use 12, negative 88, and 120, you would get the exact same answers. Okay, it would just be bigger numbers that you have to deal with. All right, so we're gonna keep cleaning this up. So a negative 22 is positive. 22 squared is 484. Negative 4 times 3 times 30 is negative 360 over 6. I'm going to move this over. And then I get 22 plus or minus the square root of 124 all over 6. And now I can separate these. So I get 22 plus the square root of 124 over 6 and get an answer there. And then 22 minus the square root of 124 over 6 and get an answer there. Okay, so don't let the quadratic formula scare you. It's just a formula. You plug the values in and you calculate. The best way to do it is calculate underneath a radical first, and then go back and go 22 plus the square root of 124. And then always make sure that you get that answer so you hit equals. And on my calculator, I've got the TI-30. It always reverts back to math print. And I want classic. So you might have to hit, I don't know if you can see this, you have to hit the mode button. So when you hit the mode and then scroll down to classic, and that will change it to where you'll get a decimal for your answer. So 22 plus square root of 124 equals, and then divided by 6. So always get that answer on top first. And I'll just round it to 4 places. And then 22 minus the square root of 124 divided by 6 is 1.8107. Okay, so if you notice, this is why you always do the endpoints. Notice the endpoints. If I didn't have the endpoints, then I would use this 5.52, and that probably would be my maximum. But because 5.52 is outside my domain, I don't need to use it because it is outside the domain, right? So you only use the critical point that's within domain. I gotta see. Excuse me. Okay, so any questions on that? All right, so now we have our endpoints. We have our critical points. And now we can just evaluate. So we have our volume at 0, our volume at 1.81, and then our volume at 5. And like we've seen, when you plug 0 into your objective function right here, you get 0 out. When I plug in 1.81 into my objective function, my dog's probably going to bark here in a minute. We're going to get 3.03, and we'll just round it to 2 places. So this is 3.03 feet cubed. I think it's in feet. Is it in feet? Oh, inches. So inches cubed. And then when you plug 5 in, that's the max, so it's going to go to 0. Okay. So here is our max volume. We have our X value, which is our height, is 1.81. And now we can find our length. Our length was 12 minus 2x. So 12 minus 2 times 1.81. And our width was 10 minus 2 times 1.81. So we get 8.38, and this one is going to be 6.38 and inches. So little those double tick marks, it indicates inches. All right, and you can see that's how we get our inches cubed. Inches times inches times inches. That's how you get your inches cubed. Okay, so the largest maximum volume will happen when we cut out squares that are 1.81 inches on all sides. And that's how we get our largest volume. Okay, so any questions on that? I can tell you the best way to get good at these is you have to just do them over and over and over again. So with that said, I opened up your MyMathLab is unlimited access because there's only 2 or 3 questions. So you can't get practice just doing it twice or even 3 times. So I want to make sure that you use that similar exercise. So give yourself enough time to do, 4 or 5, 6, up to 10 different equations, just so that you have that practice of setting it up, walking through the process, and then getting the correct answers. And it's always good to use your calculator, the one that you're going to use on the test, so that you get practice using that. Okay, so any questions on that type? Okay. And we did the cylinder already, right? Did we do the cylinder? No, we did not. Okay, so we need to do the cylinder one because it is on your test, or it is on MyMathLab. All right, so the cylinder one is you're finding volume. Here is the formula for volume of a right circular cylinder. The reason why it's called a right circular cylinder is because it sits upright. So you have a circle for a base and a circle for the top. I thought we did this one. We did do this one. Okay, we don't need to do this one again. Okay, we did do this one. Okay, yeah, that was when we left pi as pi and all of that. Okay, so you do have an example of that. All right, so let's move on. All right, so this is the very last section, part 3, and this one is called price changes. Okay, so what you want to think, this is actually very applicable, because a lot of times what happens when you're in business, if you change the price, whether you raise it or lower it, it's going to change how many products you're going to be able to sell. Okay, so for instance, in this first example, you have TVs. If I lower the price, normally what happens is it raises the number of products that I can sell. If I raise the price, it's going to lower the number of products that I can sell. So you want to get into that sweet spot where you have the perfect price giving me the perfect amount of products that I sell, which gives me maximum profit. Okay, so it's very, very handy to be able to manipulate and look at, okay, if I lower the price this much, how many products am I going to sell? If I raise the product price this much, how many products am I going to sell in that case? All right, so here we go. So the only difference is now the X represents the number of price changes. Okay, so before, when we were doing length and width, we had the L, we had the W, we knew what that meant. In revenue and profit, the X represents the number of products. Okay, in the volume ones, we have our length, width, and height, so we know what variables those are. But now in these, you have price changes. It's how many times you're going to change the price. So for instance, if I was going to change my price by $10, I was going to increase my price by $10, and my X was 3. That means that I am changing the price 3 times. So in other words, 10 plus 10 plus 10. So I'm increasing my price by $30. So that's going to be really important that you understand that the X on these price change ones does not represent the number of items. It represents the number of price changes. Okay. And you'll know on the test which one is the price changes because the prices change. That's how you know you're changing what you're looking at. Okay, so here, let's go ahead and set this up. The process is the same though. Okay, so I can't draw a picture because we're looking for maximum profit. Looking for maximum profit, so there's no picture to change. My objective is maximum profit. All right, so we know profit is my revenue minus my cost. So I have to find a revenue function and I have to find a cost function. Okay, remember revenue is everything that comes in. So revenue is the number of products times the price. And then cost is the fixed cost, if there is one, plus the variable cost. Okay. All right, so we need a number and we need a price. That's for our revenue function. So let's go through this. Electronics store sells 150 19-inch LCD TVs each month at a regular price of $300. However, the manager believes they can sell 30 more TVs per month for every $20 price reduction. Okay, so that's how you're going to know you're doing a price change. There's going to be a reduction in price or an increase in price. Okay, each TV costs the store $120, no fixed costs, and they are rolled into the big ticket item. Find the price and the quantity of TVs needed to maximize profit. Okay, so the first thing we're going to do is we're going to set up our revenue. So this is what is a little bit different from these. We're going to find the number of TVs, and then we're going to find the cost of or the price of the TV. Okay, so here's what I always say. Keep number with number, like the number of items with the number of items, and then keep the price with the price. So what's nice about that is the way this one, it just happens to set up this way. Do you see how these are both dollar amounts? That's going to be your price function. So you start with $300, but you reduce it by $20 every time you change the price. Okay, if this was a price increase, then it would be a plus 20x. Okay, but I'm keeping the dollar sign with the dollar sign because that is my price function. And then Number, I have 150 TVs. Don't let this 19 throw you. You can change this to small TVs if you want. It's very common where they throw in extra numbers that you don't need. So you sell 150 small TVs, and when we reduce the price, we're going to sell 30 more TVs. So this is keeping the number of TVs with the number of TVs. So we start with 150 TVs. When we sell 30 more every time I change the price. Okay, so what you start with is the solid number, and then the changes is where the X comes in. Okay, so I have just set up my revenue function. My revenue is the number times the price. So my revenue, oops, sorry. So my revenue in terms of X is the number times the price. Okay, any questions so far?
No.
Okay, now the reason I'm not using the cost is because cost is different, right? Cost is a completely different function. So I'm only setting up my revenue function. So now I am just distributing 150 times 300 is 45,000. 150 minus 20x or times negative 20x, x is a negative 3,000x plus 9,000x minus 600x squared. So all I'm doing is I'm just simplifying my revenue function. And I'm going to rearrange it here. So 9,000x minus 3,000x is 6,000x plus 45,000. Okay, so there is that's one of my functions that I need. Okay, I just got this one. All right, now to find my cost, it says the TV's cost, each TV costs the store $120 with no fixed costs. Okay, so the variable is 120. So my cost function, there's no fixed. So it's 120 times the number of TVs. All right, normally this variable cost would be 120 times X, but that's when the X represents the number of TVs. So now our number of TVs has changed. Right now our number is 150 plus 30X because we don't know how many TVs we're going to have, but we're going to be able to find out. Okay, so now I can distribute this, so I get my cost. So 120 times 150. If you guys get this before I do, let me know. Is 18,000. And then 30 times 120 is 3600. So 3600x. So here is my cost function now. Now I have everything I need to get my profit. Right? So it's a matter of pulling the information out and seeing exactly what it is that we're looking for. If we're looking for maximum profit, I need the revenue and I need the cost. The revenue is the number of products times the price of the products. So I was able to get the number 150 plus 30x, and the price is 300 minus 20x. When I multiply all of that and simplify, I end up with my revenue function. And then my cost is, it costs 120 per the number of TVs. And we don't know what that is yet, but we will find out. Okay, everyone good so far? All right, now we're finding the profit. So we're going to do our revenue minus our cost. Okay, so we're just going to simplify it. So my profit is negative 600 x squared. 6,000 x minus 3,600 is 2,400 x. And 45,000 minus 18 is, I believe, 27. Yep, 27,000. Okay, so here is the objective function. All constraints are plugged in. Okay, what holds us back? So in this case, what holds us back is our price. So how you're going to really know between these two, because it can change, and you'll see on another one, it does change what holds us back. In this case, it's the price. What I look for is the minus sign. Because remember, you're going to set your constraint to greater than or equal to 0. And so if we don't have a minus sign, then we're going to end up with a negative value. So negative 20, negative 20. So my x is less than or equal to, I think it's 16 2/3. Oh, no, 15. Sorry, I'm thinking of a different one. So my endpoints are between 0 and 15. Okay, so what that means is I can only have 15 changes, 15 price changes. So look at it this way. If I plug 15 into this x right here, I have 300 minus 300. That means the price is 0, right? So that's as high as I can go. I cannot go any higher than 15 price changes, or it makes my price 0. Okay, so look for the minus sign. If there's a minus sign, that's going to be your constraint. If they both have minus signs, then your price will be the constraint. Okay. All right. So we have our endpoints. Now all we need is our critical points. So we're going to find a derivative. Set that to 0. And divide. So my critical point is 2. Okay, now this is where it does make sense, because that means, remember, X doesn't mean 2 TVs, it means 2 price changes. Okay, so don't let the low number throw you. It just means that's how many price changes I can make. So when I check my volume, I'm sorry, when I check my profit, if I plug 0 into here, this is one of my endpoints. If I plug 0 into here, I'm going to get out 27,000. So what that means is if I make 0 changes, I still make $27,000 in profit. Okay, that's still not bad, but again, I want maximum profit. So if I make 2 changes, I'm going to plug it into my profit function. Because I don't want to leave any profit on the table, right? So 600, negative 600 times 4 plus 2,400 times 2 plus 27,000 is 29,400. Okay, so far that's our maximum profit. And then if I plug in 15, remember, if I plugged in 15, my price goes to 0. So I end up with negative 600 times 15 squared plus 2,400 times 15 plus 27,000. Oops. I hit too many zeros. And I get a negative 72,000. Okay, so clearly that is not maximum profit. What that means is I'm losing a heck of a lot of money by changing the price 15 times, which makes sense. If I change the price 15 times, again, that means the price is 0. So I am not making any profit at all. Okay, So my maximum profit is 29,400. Now I have to find out, because remember the question, find the price and the quantity. So I'm going to come back up to here, and plug in 2. I need more room. So my number is going to be 150 plus 30 times 2. So 150 plus 60 is 210. And my price is going to be 300 minus 20 times 2. So 300 minus 40 is $260. Okay, so here's what this means. If I'm gonna type this in here, and then I can move it. Selling each TV for $260, selling 210 TVs gives maximum profit of 29,400. Okay, so again, not making any changes, you still get a profit, right? That's what that 0 means. You still get a profit not making any changes, but making just 2 changes, dropping your price, actually allows you to sell more TVs, which gives you more profit. We had an incident of this back when I was teaching in California, that we had a music fest. And so our school was doing a fundraiser. And so we sold pizza. Sorry, Orlin and Dylan, if you've heard this one already, but we sold pizza, and we sold it for less. The price of the pizza was less than any other place. And we had people lined up around the block. We sold so much pizza. I couldn't tell you how much profit we made, but we made a ton of money. It was close to $10,000 in a 4-day weekend, just because we were willing to lower our price. And so sometimes as a business owner, you have to make those adjustments, and it does pay off in the end, because if you're competing, if you're in a very competitive market, lowering your price actually brings in more customers. As long as your product is a good product and it's comparable to the one that you're competing with. Okay, so any questions on that? The one in, and we'll get to that one in a minute. Well, let's do this one, because this one shows you, this is just like one in your My Math Lab. Let's see, and I'm going to change this one for you so that you can see what it's like in My Math Lab. My Math Lab doesn't make you do profit, if I remember right. I was helping someone yesterday and there's no profit function. So I want to make sure to get these last 2 in so that you can have an example of it. Okay, so just different terminologies. This is a different scenario. You have a pecan tree farm estimates from past records that if 20 trees are planted per acre, then each tree will average 60 pounds of nuts per year. However, for each additional tree planted, the average yield per tree drops by 2 pounds per acre. Based on this information, how many trees should be planted per acre to maximize yield? So don't let the word yield throw you. Yield just means revenue. Okay, and in this case, it is the number of trees times the number of pounds. Okay, which in essence is our dollar amount, because the more pounds of fruit we have, the more money we're going to make. Okay, so number of trees times the number of pounds will give us our yield. So in this case, all we're doing is we're finding revenue. So we don't need cost. There's no cost because we're not finding profit. We're finding yield or revenue. Okay, so we're going to set it up the exact same way. The number of trees, and I'm going to keep it as dollar amount just to make sure that there's a difference, but dollar amount and the pounds of fruit is the same thing. Okay, so here we go. We found 20 trees, and each tree will average 60 pounds. Okay, so we have 20 trees and each tree yields 60 pounds. So do you see how I'm separating them? I have so many students that put those two together, but we're actually writing two different functions. And then for every additional tree planted, so that is one change, our yield drops by 2 pounds per acre. So every time I add a tree, I'm reducing the number of pounds by 2. Every time I add a tree. Okay, so I want to make sure that you see exactly how this works. So this and each additional tree go together. That's the number of trees. And then the pounds goes with pounds. And that is our dollar amount or our value, if you will. Okay. So any questions on that? Is it pretty clear how to pull the information out?
So X is the number of acres, right?
No, X is the number of changes.
Oh,
So in this case, we're changing by adding trees. So X is always the number of changes that I'm making, because with each change, right, I drop my product by 2 pounds.
okay.
Okay. All right, so our yield is the same as our revenue. So that is the number times the price. Let me do my dollar sign instead. Okay, so our yield is the number of trees times the price of the tree. Okay, so now I'm just going to clean this up. So 20 times 60 is 1200. 20 times -2 is -40x. X times 60 is 60x, and x times -2x is -2x squared. So my yield function, and notice we have all x's, right? That's the important part. So -2x squared, 60x minus 40x is 20x plus 1200. So there is our objective function. Okay, so out of these two, which one do you think is the constraint? Which one is going to hold us back?
Number trees.
Okay, so remember, you always want to look for the minus sign, because I can add as many trees as I want. But what that does is it affects the fruit, because, and this is a real thing, in agriculture, the tighter and compact the plants are, they're getting less sunlight, less nutrients, less water. They're having to compete with all the other plants. And so spreading it out actually allows your plant or tree to produce more product, right? And because this is a business, we want the most product that we possibly can, which is the yield. We want the most yield. So what actually holds us back is the amount of fruit that our trees can produce. So again, look for that minus sign. That's going to always be the tell.
So it would be just like the other ones that we've been doing.
Yep.
With the minus. Okay.
Yep. There's always going to be a minus sign. And really, if let's just say I went with the 20 plus X, well, watch what happens. Remember, the whole goal in finding endpoints is to say that we're only dealing with positive values. Well, when I subtract 20 from both sides, do you see what happens? I end up with a negative number of trees. Or not, I'm sorry, a negative number of changes, right? Well, that doesn't make any sense. So I don't want any values that are negative. So that's why when there's a minus sign, that's why it works. Because when I bring this 60 over, it becomes a -60. And then when I divide by a negative, I end up with x is less than or equal to 30. Okay, so my endpoints are between 0 and 30, and it's all positive. So that's kind of one of those things, if you aren't sure, or if you pick the wrong one and you end up with a negative endpoint, you know, you picked the wrong one. All right, so then go to the other one. All right. Okay, so now we're going to find the derivative. So we got negative 4x plus 20, set our derivative to 0, and solve. So we get our x equals 5. So this is our critical point. Okay, so now we can check. When I make 0 changes, when I make 5 changes, or when I make 30 changes. So 0 changes, I'm still going to end up with 1,200 pounds of fruit. All right, that's good. That's still a very good yield, right? 1,200 pounds. Because if you remember, we started with 20 trees. Each tree produces 60 pounds. Well, 20 times 60, there's your 1,200. Okay, so no changes, I still get 1,200. But if I make 5 changes, in other words, in this example, the 5 does represent the number of trees. So I have 25 times -2 is -50 plus 100 plus 1,200. So I get 1,250. And then the 30, I'm going to end up with 0 again. Okay, so just adding 5 trees adjusts the number of fruit, the amount of fruit that will be produced, but it actually gives me a maximum yield. Okay, so you can think about this as like revenue. This is my maximum yield or maximum revenue. All right, so now we got to find out, okay, we're making 5 changes. So now we're going to go back up here and plug that 5 in. So with 5 changes, I get 20 plus 5. So I end up with 25 trees. With 5 changes, I get 60 minus 2 times 5. So each tree is going to give 50 pounds. So yes, it's less, but I have more trees. All right, so because it's yield, if I do 50 times 25, I am going to get that 1,250. So when it's revenue or yield, then you can double check to make sure that your answers make sense. Okay, so if each tree is 25 trees and each tree produces 50 pounds, I'm going to get a total of 1,250 pounds. So the interpretation, and again, this is how you guys are going to earn credit. The interpretation is planting 25 trees where each tree yields 50 pounds of, I think it's pecans. We get a maximum yield of 1,250 pounds. Okay, any questions on that one? Okay, so the last one we're going to do, I'm going to change this because we've already done one profit. We don't need to do another one. So don't worry about the term gross profit. Gross just means the maximum profit, but we're going to do maximum revenue because that will be closer to what you're going to see in your MyMathLab. Okay, so we're just going to look for maximum revenue. Okay, so the scenario is 300 rooms, in the hotel in Las Vegas, filled to capacity every night at $90 a room. For each $3 increase in rent, 5 fewer rooms are rented, right? Makes sense. The more you increase the cost, the fewer rooms that you're going to rent. So how do you find that sweet spot, right? And for this one, we don't need the cost because we're not finding profit. We're only finding revenue. Okay. So this one, we need 2 things. Revenue is the number of rooms times the price of the room. Okay, so our number function is we start with 300 and we have 5 fewer rooms. So put those together. So you end up with 300 minus 5 times the number of times you change it. Okay, and then the dollar amount is we start with 90 and we increase by $3. Okay, so the dollar amount, we start with 90 and we increase it by $3 every time we change. So if I make a price change once, it's $3 more, so 93. If I make a price change twice, it's going to increase by $6. If I make a price change 3 times, it's going to increase $9. Okay, so every time I make a change, it's going to increase in intervals of 3. So there's our dollar one. Okay, so this one, Orleans, do you see how this one's different now? Now the number is our constraint because the number of rooms is what's going to limit us. We only have 300 rooms to deal with. We can't rent out 310. We can't rent out 315. We only have 300. And so the number of rooms is what's going to limit us. So this is our constraint, is the 300 minus 5x greater than or equal to 0. So we want the number of rooms to be our constraint, excuse me, our constraint. Okay, so this means we can only have 60 changes, 60 increases in cost. And if you notice, if I plug 60 in right here, -5 times 60 is -300. So 300 minus 300, if I increase the price 60 times, I'm going to have 0 rooms rented. Okay, which makes sense because if you increase too much, and I've seen it where, in fact, because of the eclipse, I've seen prices go sky high. And so like out here in Kerrville, people are getting a little too greedy. And so they haven't been able to rent their like their Airbnbs and the hotel rooms. There was still openings in the hotel rooms because they jacked up the prices too much and people weren't willing to pay it. So now that it's getting closer, they've lowered the prices and now people are starting to show up and rent for the weekend. Okay, so here we go. We're looking for our revenue. The number times the dollar amount. Okay, so now we're going to clean it up. So there's a fly. I'm not going crazy. There's a little tiny gnat. I don't know if you guys can see it on the camera or not. There's a little tiny gnat bugging me. I'm not just waving in the air, I promise. Okay, 300 times 3x is 900x. -5x times 90 is -450x. And then -5x times 3x is a -15x squared. So I'm going to rearrange this and simplify. 900 minus 450 is 450x plus 27,000. Okay, so we have our endpoints. Our endpoints are between 0 and 60. Now we can find our critical points. So finding the derivative. We're going to set that to 0 and solve. So we have 50. Hopefully this is all very second nature to you, this solving. So we get x equals 15. Okay, so here's our critical points. 15 does fit within what we're looking for. So when we have 0 changes, when we have 15 changes, and when we have 60 changes. Okay, remember we're plugging it into this one right here. This is our objective function. So when I make 0 changes, so again, I'm still making revenue, right? 0 changes, I'm still making money. But again, I want maximum revenue. So if I make 15 changes, oops. Number doesn't look familiar. Hang on. I have it done right here. I'll just make sure. I've done these so many times, I have an idea. Oh, I know why. Okay. Because I changed the question. All right, so we have $30,375 is our maximum, is our revenue. And then if I make 60 changes, remember we said, oh, if I make 60 changes, I'm going to end up with 0 rooms. So I have 0 revenue. Okay, so we know we can make 15 price increases. So we're going to come back up here and find our number of rooms is 300 minus 5 times 15. So we can rent out 225 rooms. And we can charge 90 plus 3 times 15. So $135. Okay, now if I do 135 times 225, when you multiply these, you get 30,375. Okay, so we know that these two numbers are correct. All right, so renting out fewer rooms, but being able to increase the price gives us maximum revenue. All right, and that's just good business. So if you can go, if you're in a company, whether you're the owner or whether you are working for an owner, man, what a good trait to have, to be able to go, you know, if we adjust our prices, we're going to sell more products. Or if we increase, you know, in this case, we increased our prices, and even though we rented fewer rooms, we still are making maximum revenue. Okay, so any questions on any of those? Hopefully this one, I think there's 3 questions on part 3 and 2 or 3 questions on part 2. So it's not a ton of work. And I didn't want to give you a whole bunch, but I want you to put in the time just doing them over and over and over and over and over again so that you're ready for your test. Okay. All right. That's all I have for today. If you have no questions, I will hang out You can ask, or I will see you on Tuesday.
Bye, ma'am. Have a nice weekend.
All right, you too.
Ma'am,
Yes, sir.
I just wanted to ask for the test supplements. Uh, do I just do one of them or do I have to do both?
No, you just pick one. And so
Pick
be
one?
strategic about it. You pick the one that you need to improve the grade on. So, do the lower one, and that way, when I average the two, it'll improve the grade.
Okay. Okay.
Yeah.
Thank you, ma'am.
And then, and Mahmoud, you're gonna take the test next week early, right?
Oh yeah, never mind. It was the holiday is a different day. It's another day.
Oh, okay. Okay.
Yes, ma'am.
Okay. So you're good on Thursday then?
Yeah.
Okay,
Yes, ma'am.
perfect. Okay.
Thank you.
All right. Have a good weekend.
You too. Bye.
All right. Bye-bye. Adam, are you good?